This activity allows students the opportunity to use tools, select materials, and construct a hydropower generator that will actually generate a small amount of electrical power, similar to how a real hydropower generator would work. The model described in this unit has been built and tested, but you should also feel free to modify it to fit your needs and to encourage your students to think about ways to improve the design themselves. The written instructions break down this process, but let's walk through the build step by step together. To build the generator, you'll need a rectangular plastic jug. Print the turbine unit templates from the PDF instructions. You'll need a pair of scissors to help with the build. To build the rotor, you'll need a 1/4 inch wooden dowel rod, a hub made from 2.5 inches of this styrofoam rod, a rubber stopper that you'll need to cut in half, and 8 plastic spoons. To mount the coil and magnet assemblies, you'll need 2 CDs. Grab 4 3/8 by 1 inch bolts for the wire assembly. To generate electricity, you need to change a magnetic field, so you'll use 4 alternating neodymium magnets. This magnetic wire will give the magnets a path through which to push and pull those electrons, creating and generating a current. This model generates electricity, but you can also mount a small motor to generate as well. To complete the build, you'll need some tools and materials starting with tape. You'll be drilling some holes, so a power drill is necessary. To drill the hole, you'll need a 1/4 inch drill bit. A hot glue gun is an essential maker tool. Be careful though. You'll need a large nail, a box cutter, and adult supervision. To make precise measurements, you'll need to measure with a ruler. To mark the measurements, grab a permanent marker. Find a pencil sharpener big enough to sharpen the dowel rod. Since the model generates electricity, you'll need a multimeter to read that output. You'll use alligator clips to connect the multimeter to the generator model, and a bit of sandpaper to help with the connection. Let's start building our generator by preparing the jug and AXEL. Use the pencil sharpener to sharpen one end of the wooden dowel. Set it aside. Stand the jug on its bottom with the mouth of the jug facing you. Using a ruler and a permanent marker, make the following marks. Start with a mark on the left side of the jug. From the bottom, measure up 1.5 inches and 8.5 inches and make horizontal lines. From the center line of the narrow left side of the jug, measure 1 inch on each side off the center. This will give you a 2 inch by 7 inch hole to cut out using a sharp utility knife blade. Position the jug so that the mouth of the jug is on the left and mark the center line of the AXEL hole. Measure from the bottom of the jug up 4 5/8 inches and from the left 3 inches. Where these two marks intersect, drill a 1/4 inch hole. This hole must penetrate completely through the jug on both sides to be level. The hole on the other side of the jug will be 4 5/8 inches up and 3 inches from the right side of the jug. You can always remeasure if you're unable to drill through the whole jug. This hole should end up being just slightly larger than the diameter of the dowel rod, so the dowel rod can spin freely. The recipe for electricity generation requires changing a magnetic field. This interaction takes place as the magnet assembly spins past the coil assembly. Make the 4 coils by wrapping 300 turns of magnetic wire around each 3/8 by 1 inch bolt. Wind each bolt in the same direction, clockwise or counterclockwise as you look at the head end of the bolt, leaving at least 4 inches of wire between each bolt. Do not cut the wire between each bolt, but keep the wire as one continuous piece. Secure the wire with tape or hot glue to prevent it from unwinding before you start the next bolt. Use the CD and permanent marker to recreate the winding template. Draw the bolts as capital T's, paying attention to whether the bolts should be facing inward or outward. Use the hot glue gun to attach the bolts to the CD, keeping the ends of the wire free and extending out from the CD. The 4 magnets should come stacked. Caution, the magnets are very strong. Take care not to pinch your skin between them and keep them away from electronic devices. On the top face of the magnet, mark an N to indicate north pole of the magnet. Remove the top magnet by sliding it off and mark the top face of each remaining magnet with an N. Place the magnets on the table far from each other so they don't fly towards each other. The blank faces of the magnets, the opposite sides, will indicate the south pole of the magnet. Use the CD and permanent marker to recreate the magnet CD template. Write capital N's and capital S's to indicate the position and pole of each of the 4 magnets. Using the hot glue gun, glue the magnets one at a time to the CD as indicated on the template. If the CD says N, face the N on the magnet upward. If the CD says S, face the blank side of the magnet upward. The water pushes against the spoons in the turbine to spin the rotor and therefore the magnets. Let's cut our hub and attach the blades to create this turbine. To cut the foam hub, measure 2.5 inches on the foam rod. Then cut the foam by scoring around the entire rod with your scissors, and it should snap off easily. Cut out and tape the hub marking guide to one end of the foam hub. Extend the lines down the sides of the styrofoam with the marker, so you have 8 parallel lines evenly spaced around the hub. Use a ruler or straight edge to keep your lines straight and evenly spaced. Measure the center of your styrofoam hub at 1¼ inches and make a line around the hub at this point. Measure from the bowl end of each spoon down 3½ inches and make a mark with the permanent marker. Carefully cut off the excess handles. Consider wearing goggles during this portion of the build. Push the spoons into the styrofoam hub at the middle of the hub, one at each mark. Insert the spoons only about 1/4 inch to hold them in place, making sure that they are evenly extended from the hub. Hot glue the spoons in place to hold them tight. They should flex very little, if at all. They're going up against the force and weight of water. All of these individual parts come together with the motion of the water to build a hydropower generator model that'll actually generate electricity. Use the hot glue gun to attach the winding assembly to the outside of the jug, with the hole of the CD centered around the hole that you drilled on one side of the jug. Use a nail to start a hole in the center of the styrofoam hub so you can see where to push the dowel rod through the hub. Push the sharpened end of the dowel rod into the jug from the side opposite of the glued winding assembly. Position the styrofoam hub in the jug. Continue to push it through the center of the styrofoam hub inside the jug and out the jug through the hole of the winding assembly. The pointed end of the dowel rod should protrude several inches from the jug and winding assembly. Cut the rubber stopper in half crosswise so you have 2 pieces with an intact hole in the middle. Slide the narrower rubber stopper piece onto the dowel rod with the wider end facing the jug and the narrower end facing the pointed end that extrudes from the dowel rod. Position the rotor so it is centered based on the position of the rubber stopper. Slide the other half of the stopper onto the dowel rod with the larger side facing away from the jug. Hot glue the CD with the magnets onto the larger end of the second half of the rubber stopper. Make sure that the magnets are facing outward, away from the jug. This will keep the magnets from pulling the stopper down and causing the magnets to attach to the winding assembly. Give the rotor axle, the dowel, a spin with your fingers to ensure that everything turns smoothly and nothing is rubbing or causing friction with another part of the assembled model. Use sandpaper to gently scrub off the insulation from the ends of both of the long pieces of wire on the winding assembly. This is the site to which you will make any connections for measurement and testing. You'll notice that the enamel, the red paint, is worn off when you see a more copper color come through. From here, you can attach your multimeter using alligator clips. Connect the multimeter to the sanded lead wires on your generator. Set the multimeter to 20 milliamps to read the current. You can test it manually by spinning the dowel rod, your rotor. When the rotor spins, the magnet spins, and change the magnetic field. When we change the magnetic field, we push along those electrons, creating and generating a current. You can also test your model using a hose, river, or even a bathtub. When water runs through the mouth of the generator, the spoons spin the hub, spinning the motor and therefore the magnets. Since the spoons extend from the jug, you can also generate electricity by running water along the outside of the jug. You can adjust the flow of water and the position of the magnet CD to try to optimize the electrical current being generated by your hydroelectric model.